This is Algebra 2, Chapter 4, Unit 5. Complex numbers. Complex numbers are usually denoted as C in parentheses. So let's consider the number 5 plus 2i. Remember that I stands for an imaginary unit. Usually I equates to -1, the square root of -1. Because 5 is a real number and 2i is a pure imaginary number, they are not like terms and cannot be combined. This type of expression is called a complex number. The standard form of a complex number is a plus bi. So the real part is a and the imaginary part is bi. Adding and subtracting complex numbers. First, we want to simplify the expressions. The final forms must be in a plus bi form. So let's look at some examples. Our first example is the -11 plus 3i plus 9 plus 2i. Okay, so we want to combine like terms. In this case, -11 and 9 is a like term, and 3i and 2i are like terms. So when we take -11 plus 9, that we're going to get -2. And when we take 3i plus 2i, we're going to get 5i. Now we have, for number 4 on your note packet, we have 6i minus parentheses 14 minus I plus 5 minus 3i. Here we also want to combine like terms. And we also have this negative right in front of this parentheses. So we want to distribute this negative to both the 14 and the I. So it becomes -14 and positive I. So we have -14 plus 5 equals -9. And then we have 6i plus I minus 3i. So 6i plus I equals 7i, and then minus 3i equals positive 4i. Now I would like you to pause the video and try numbers 2 and 3 on your own. When you're ready to start again, push play. Here are the answers to numbers 2 and 3. Now let's move on to multiplying complex numbers. So, like adding and subtracting, it also must be in a plus bi form. So let's look at number 5 on your note sheet. We have 2i times parentheses 8 minus 3i. So in this case, can you guess what property we're going to use? Correct, we're going to use the distributive property. So when we take 2i times 8, we're going to get 16i. And when we take 2i times -3i, we're going to get -6i squared. So, as from earlier videos, we know that I squared equals -1. And when we take that times -6, we're going to get positive 6. So, since we have a positive 6, we're going to put that as our A, so in front, and it's going to be 6 plus 16i. Now, here is number 10. A little bit more work to it, but we can do it. So we have 1 plus 7i times 9 plus 3i minus 4 plus 2i. So we have both multiplication and we have subtraction going on here. So when we go ahead and distribute the 1 times 9, we get 9. 1 times 3i, we get 3i. 7i times 9 equals 63i. And 7i times 3i equals 21i squared. And then we distribute this negative sign. So we have negative 4 and negative 2i, just like what we got right here. So when we combine like terms, we notice that we have, we're going to get rid of this. Since it's I squared, we're going to get rid of this and turn it into a negative 1. So we're going to take 21 times negative 1. We are also going to combine our 3i and our 63i and our negative 2i. And when we combine those, we get a positive 64i. We notice how we haven't combined this negative 4 and this 9 yet, because we're waiting to combine the i's to see if there's anything like this that we could turn into an integer. So we have 9 plus negative 21, which gets us negative 16, and then we have 9 plus negative 21 minus 4, which gets us to negative 16. And then we have positive 64i. Now, if you would, try numbers 6 through 9 on your own and pause the video. Here are the answers to 6 through 9. Now we are moving on to complex conjugates. So two complex numbers in the form of a plus bi and a minus bi are called complex conjugates. The product of two conjugates is always going to be a real number. So let's look at some examples. We have 8 plus I times 8 minus I. When we go ahead and distribute, we got a times 8, which equals 64. 8 times negative I, which equals negative 8i. I times positive 8, which gets us positive 8i. And positive I times negative I equals negative I squared. When we combine our like terms, we can combine negative 8i plus 8i, and that cancels each other out. So we would be left with 64 minus I squared. When we take I squared and translate that, so we have negative I squared equals negative I equals positive 1, so 64 plus 1 equals 65. Now do number 12 on your own. Here is the answer to number 12. Dividing complex numbers. So we want to watch out. I cannot be in the denominator of a complex number, just like we can't have square roots as a denominator or fractions. If the denominator is a monomial, we want to multiply the top and bottom by the monomial. So monomial, as you remember, mono means one, so one element. If the denominator is a binomial, multiply top and bottom by the conjugate. So let's look at some examples. We have number 13 on your note sheet. We have 10 divided by 2i. We want to take 10 divided by 2i and multiply it by top and bottom by I to get rid of the bottom I. Once we do that, we have 10i divided by 2i squared. Now we remember, what does I squared equal to? Negative 1, correct. So we're going to have 2 times negative 1 on the bottom. So our answer is going to be 10i divided by negative 2. And when we reduce that even further, we get negative 5i. Next one, we have negative 8 minus 2i divided by 6i. We want to get rid of that I on the bottom, so we're going to take the top and bottom and multiply them by I. Because when we multiply the bottom by I, we're going to get I squared, which equates to negative 1. So we have negative 8 minus 2i times I. So we're going to use a distributive property and on the numerator and distribute that I. So once we distribute that I, we're going to get negative 8I minus 2I squared, and on the bottom, or divided by, 6I squared. Well, I squared equals negative 1, so negative 2 times negative 1 will become a positive 2, and then we have negative 1 times 6 will get us a negative 6. Now remember, our form for multiplying these imaginary numbers, our complex numbers, is our a has to be, or our integer, our real number has to be in front, and our imaginary number, or I, has to be behind the real number. And when we reduce that, we're going to reduce 2 by negative 6, which gets us 1/3 and negative 3. And then we can also do 2 divided by negative 6, which gives us 8 divided by negative 6, which gets us negative 4 and negative 3. Okay, now we have number 18. We have 5I divided by a conjugate of 6 plus 2I. So, according to our notes, we have to multiply top and bottom, or numerator and denominator, by the conjugate. So, we take 5I times 6 minus 2I for the numerator, and 6 plus 2I times 6 minus 2I for the denominator. Why do we do negative? Because we want to do whatever we can to get rid of that middle number on the bottom. So 5I times 6 will get us 30I. 5I times negative 2I will get us negative 10I squared. And then we have 6 times 6, which equals 36. And then we have 6 times negative 2I, which gets us negative 12I. 2I times 6 gets us positive 12I, and then 2I times negative 2I equals negative 4I squared. So once we combine these, we notice that we have an I squared on our numerator, so that equates to negative 1. So we take negative 10 times negative 1, which gets us positive 10. So it's a real number, so we're going to move that into the front of our numerator, and because real numbers are at the front before imaginary numbers. And then we have a positive 30I. Well, when we combine these two cancels out, the 12i's, and negative 4I squared becomes negative 4 times negative 1, which equals a positive 4. 36 plus 4 equals 40. Go ahead and reduce, and we get 1 plus 3I divided by 4. Now I would like you to try numbers 14, 15, 17, 19, and 20 on your own. Go ahead and pause the video so you can try them. Here are the answers for those numbers. Now that concludes part 1 of Unit 5. Once you feel ready, please go ahead and move to part 2 of Unit 5.